The concentric circles in the diagram share center C. Diameter segment TV of the outer circle bisects chord segment AB of the inner circle at point J. Diameter segment TV of the outer circle also bisects chord segment EF of the outer circle at point K. If the measure of angle EKT is equal to the quantity of 5x plus 65 degrees, and the measure of angle BJT is equal to the quantity of 85 plus x degrees, what is the value of x? Okay, so in this lesson we learned that concentric circles, meaning that they share the same center. So point C is the center of the blue circle and the green circle. If they are cut on the diameters of both of the circles, these chords right here, whatever angles they form are going to be equivalent. So like angle FKC, this angle would be equivalent to this angle. And this angle CJA would be equivalent to this angle VKF. So it's cutting them to where these four corresponding angles are going to be congruent. Since the angle EKT, they're using this point out here, and BJT are in the same spot, they're corresponding angles. So like if I were to look at these four angles, this is spot 1, spot 2, spot 3, spot 4. And then I would order these four angles again where this intersection is in the same order, 1, 2, 3, 4. Since they're in the corresponding, the lower left area, they're corresponding angles. That means that they're equal to each other. So we know that angle EKT is going to equal the angle of BJT. So now we are given that these two angles, angle EKT is equal to 5x plus 65 degrees. So I'm going to replace that where that's at in this equation. And BJT is equal to 85 plus x. So that's what I'm going to replace it with in this equation. Now, again, if you did not watch the previous one, since there's not a number that's larger than 1, there's always like a ninja 1 implied to anything with parentheses. Since it's not larger, since there's not a 2 or a 3 or a -1, we can drop these parentheses. So now that we have 5x plus 65 equals 85 plus x, notice first we have x's on both sides of the equal sign. So I'm going to collect all of the x's. I'm looking at 5x and x, and I'm asking myself which quantity is larger, 5x's. So I'm going to subtract the x from both sides. Now you might be thinking, well, it's just x. What value is in front of it? This is where math is implied. So if there's an x, there's always a value of a 1 implied with it because you wrote 1x. It was there. So 5x minus 1x is equal to 4x. 65, positive 65 plus nothing is still positive 65. That equals, we still have our equal sign, 85 plus nothing is still 85, and 1x minus 1x is plus 0x. Now 0x means 0 quantities of x. So if I have 0 quantities of it, I'm not going to write it. It's redundant. It's not needed. So now notice I have 4x on this side and a number, a constant, and then my others. So I want to remove this number and get it on to the right hand side so that it's with its like terms. So I'm not going to ask myself which one's larger because I want to move the number that's by the x. So that is just given. I want to move whichever one's by the x. So I'm going to subtract 65 from both sides. So 4x minus nothing still leaves 4x. Positive 65 minus 65 leaves plus 0. Since 0 doesn't change the value of anything, it's not normally written. So that's why it usually appears like this. And then 85 minus 65 is 20. So now we have 4x is equal to 20. Since 4 is multiplying the x, we are going to divide it, which is the opposite operation or inverse operation. We're going to divide it by 4. The reason being is because 4 divided by 4 reduces down to 1. So 4x divided by 4 reduces down to 1x because 4 divided by 4 reduces down to 1. This is going to equal 20 divided by 4 is 5. Typically you don't see the 1x again because it's implied, so you would normally just see x equals 5. That means the value of 1x is equal to 5 units. So x is 5.